Hello, Jamin. I am GK Saran and you are watching my channel GK Tech 2017. You've seen in ships the running of generators. When the load is less, number of generators running is only one. Say for example, in the anchorage, only one generator is sufficient to supply all the loads. But what if the load increases? The number of generators needed will be more than one. So here comes the question of synchronization and bringing the just started generator to a synchronized manner along with already running generator of the bus bar. And upon being synchronized properly, it is connected to the bus bar to supply the loads along with the already running generator in parallel. This is called the parallel running of the generator. The process which is done for the parallel running of the generator just before the starter generator being connected to the bus bar is called the synchronizing process. So this we are going to discuss today. Today's topic of discussion is synchronization of generators. So there must be a way in which we can synchronize the generators properly. And the process to synchronize the generators is to keep an eye on the parameters to be made equal. Parameters are number one is voltage, number two is frequency, and number three is phase. So we're going to discuss one by one. Let's first discuss on voltage. Let's take the voltage form of one generator in the sinusoidal form. Here you can see that the voltage of one generator is sinusoidal form. Let's make one more curve for the another generator. This one is for voltage of generator number 1, V1. The other one is voltage of second generator, that is V2. Let's say we take 1 point. Here you can see that voltage profile of the two generators is such that the voltage of one generator is V1, voltage of the other generator is V2. V1 is greater than V2. So current will flow from V1 to V2. That means from generator 1 to generator 2. So instead of the power being supplied to the loads, power from generator number 1 will go to generator number 2, which is not our aim. Our aim is to provide the current or the power to the loads on the ship, not to the other generator. How it can be rectified? That can be made sure by ensuring that the voltage difference as here can be nullified, or in simple words that profile of the voltage generated by the second generator is overlapping right onto the profile of the first generator V1 here. So at no points there is any voltage difference between V1 and V2. So now there will be no circulating current between the generator number 1 and generator number 2. This is the first correction we have to make. That means the voltage should be made to be equal to the voltage of the bus bar. Let's have a look at the second condition, that is the frequency. What will happen if the frequency of incoming generator is different from bus bar frequency? Shown in the diagram is a profile of the already running generator. At this point, generator number 1 completes one cycle. Let's draw the profile of incoming generator. One in the orange color for the profile of the generator number 2. This is for one cycle of G2. In this case, let's take one timing at this point. This is V2. This is V1. At T1 seconds, V2 is greater than V1. So current I will flow from generator number 2 to generator number 1. And let's take a different timing. Let's say at this point. This one is V1, here it is V2. So at T2 seconds, V1 is more than V2. So current I flows from G1 to G2. So the flow of the current will be alternately going from one generator to another generator. Instead of the generators providing the power to the loads on the ship, part of the power produced is going to the other generator. It is a loss to the power produced by the generator because this power that is going to the other generator from one generator, it would have been used for the loads on the ship. So we have to make a rectification. We have to ensure that the voltage profile of one generator is overlapped by the voltage of the other generator. You can see the curve for the another generator in the green color as we go on reducing. Right at this timing, it is completely coincided and overlapped to the already running generator profile. That means they are completing one cycle at the same timing. Just take any point. As the voltages are same for the two generators, V1 is equal to V2. So upon reducing the time period and making it overlap with the already running generator or the busbar frequency, there is no potential difference at any point. So we can say now potential difference is 0. So current I flow is nil. So no circulation of current and power between the generators. This is the reason why the frequency has to be matched so that it can be synchronized and taken on load. Let's have a look at the next criteria, that is the phase. Phase is that when you compare between two generators, the difference in the times between the two generators profiles to reach at the same status either for zero value or maximum positive value, maximum negative value. The time difference they take is that which mentions about the phase. Let's have a look at the diagram. Now we can see that the running generator is completing one cycle at this point. Let's say we have started one more generator. The orange colored one is for the incoming generator profile. At any position of time, let's say at this position. The voltage of generator number 1 is V1 and for generator number 2 is V2. V1 is greater than V2. So current I flows from generator 1 G1 to G2. Now let's take one more timing, say at T2. This one is for V2. Voltage of number 1 generator is V1. So at time T2 here it has got reversed. Now V2 is greater than V1. So current I flows from G2 to G1. So the current will be flowing alternately from one generator to another. The circulation of the power will be from one generator to another and vice versa. It is a loss to the power produced because this power which flows between one generator and the other generator, it could have been used somewhere in the loads. To rectify, the profile of one generator should be overlapping over the profile of the other generators, and that can be done by ensuring that the both the profiles are starting and ending at the same timing. So we have to begin at a little bit earlier time so that it coincides and overlaps that of the black colored profile. Now exactly at this point, you take any timing, say here, here or any time. At all the times, the voltage differential or the potential difference is 0. So no current or power flow from one generator to another generator. And this way, three conditions that the voltage, frequency and phase have to be matched properly. It is called the synchronization process before being connected to the bus bar so that they can run in parallel. When more than one generators are running, they are said to be running in parallel. Here it is important to mention that the voltage and the frequency have to be kept a little bit more so that when it is connected to the loads, upon being loaded, it will come back to the normal voltage. The RPM also will come down by a little amount and thereby reducing the frequency. And the frequency now will match with the buzzer frequency. And while synchronizing, as you have seen in the synchroscope, that is just like a wall clock with the with one pointer rotating in the clockwise direction. And the right time to push the breaker is at the 11 o'clock position. So that by the time it reaches the 12 o'clock position, the breaker just closes and takes the generator on load. One thing is that if the frequency or the phase or even the voltages are such that there is a huge difference between the two profiles. In that condition, if it is loaded and taken on load, there might be a huge spark in the SCB contacts. So these things we have to keep in mind. So this is all about today's video. I'll be presenting on a different topic in the next video. Share this video among your friends so that they can also get some benefit out of it. Please give it a like. More the number of likes this video gets, so that more people will get a chance to see this video. Put down your comments with any kind of videos you might want to see, upon which I'll be making the videos. See you in the next video. Till then, do take good care of yourselves. Bye bye.